Alrighty, now the next type of probability rule or type of probability is called conditional probability. And it's denoted as the following. It says the probability of A given B. And this is the probability that event A occurs given that B has already occurred. Now, some key words you should look for in conditional probability are saying if B has happened, given that B has happened, assume B has happened. And that's represented by this bar here. So this bar really means given, if, assume. Now, this formula is also on your AP Stats formula sheet. So it says the probability of A given B is essentially the probability of both divided by the condition. So here I've got this is what we call a probability tree diagram. And we'll actually do some work with this in the next lesson. But here's the connection between the two-way table and the tree diagram. So first you have two branches, either B does happen or B does not happen. And then from there, A happens or A does not happen. So let's say B is the probability, or B is the event you're running late. So you either are running late or you're not running late. Then A, let's say, is the probability you get breakfast if you're running late. And the probability you don't get breakfast if you're running late. And the probability you get breakfast if you're not running late, probability you don't get breakfast and you're not running late, given you haven't ran late, etc. So these branches here just stem off into the different conditions. So here, notice that each of these, either A or A naught, occurs after B or B naught has occurred. Now, in notation here is event B. So here's event B. All of this is event B. Right, so that is the total. Now, the area that I'm interested in is the both section. So for both, so that would be this. It's basically the green over the yellow. So I want the both over the condition. So as a result, we have the following. PA given B is the same as PA and B divided by PB. And we also could use the alternative to that. It could also be P of B given A, which not much changes. It's still going to be the both in the numerator, and then in the denominator, it's just the condition. So it doesn't matter what the given is, it just will tell you that, hey, this if there's a conditional probability, the numerator is their intersection, the denominator is that condition. Well, as a result here, we have the following situation. So you have to go through B first and then A can occur. Well, so that's going to be one pathway on this train here. So here's the first pathway. Then you could have pathway number 2, pathway number 3, pathway number 4. So 4 separate pathways. And each of those pathways, since you have 2 events happening, we can actually find the intersection. So notice here, this is as P of A given B and the probability of B. Well, if I rework this, as a result, this is what happens. The probability of A and B equals the probability of A given B times the probability of B. So to find the intersection, the green section here, I'm just going to multiply the conditional probability by the condition, and that'll help me find the intersection. Then from there, we'll be able to apply some of our probability rules. But for the most part, we're just going to practice identifying and finding these probabilities, and then in future lessons, we'll learn how we can actually apply conditional probability. Now, I'm going to do something a little out of order here. This says example 1, but you'll notice it's very formulaic. So I'm actually going to leave that one to you to try it out. So what's going to happen, though, is let's do this word problem together. And most conditional probabilities, what makes them difficult is that they're typically given in a written form or with just the table. So you have to be able to have fluency in both of those versions there. So really communicating what the words are saying into probability statements. So here, a small university takes a random sample of first-year students relating the grade they received in the course and the school they received the grade from. Here, event E means that the grade comes from the engineering and physical sciences. And here, event L means that the grade is below a B. So we have each of these, the two-way table, which represents the school and the grade level. And then here we have the frequencies. So here, we want the probability that the student earns a grade lower than a B. So we want the probability of L. Okay, so let's go to the total. Below B would be 3,656 out of 10,000. And again, I feel like I put an extra 0 there. Oh, that's 1,000. I can't do this, sorry, y'all. All right, so again, you just need a fraction at a minimum, but of course, we can also rewrite this as a decimal, but at a minimum, you do need the fraction. So our first one, the probability that you get a grade lower than a B is going to be 3.3656. Next up, we want the probability that someone earns the grade from the EPS course. Okay, well, let's look here. Those from engineering and physical sciences, it's going to be 1,600 out of 10,000. So 1,600 out of 10,000, that's going to be about 0.16. So far, so good. We're just identifying from our table. Now here, we want the probability that someone earns a grade from the EPS course and it's lower than a B. So again, that's going to be out of our 10,000 possible observations. So below a B, and it's from the EPS, well, that's going to be this bad boy right here, 800. So now I have 800 out of 10,000, and that's going to give me about 0.008. Or just 1.8. 1, 2, yeah, just 8. So I have probability lower than a B, probability it's from the EPS school, or probability that it's lower than a B and it's from the EPS. So now let's actually look at a conditional. So find the probability someone earns a grade from an EPS course. All right, nothing too fancy yet. So probability they earn it from an EPS course given, which is the bar here, it's below a B. So now we have probability of E given L. Just as a reminder, the numerator is going to be the intersection of both events, and the denominator is that condition. Well, here we have the probability of E and L is going to be 0.08, or what we can do here, that's 800 out of 10,000. And the probability it's lower than a B was going to be 3,656, also out of the 10,000. And note here that these have the same denominator, so they're going to actually cancel each other out. So I actually have 800 out of 3,656, which is approximately 0.2188. It's about a 21% chance that given the grade is below a B, it's going to come from the EPS course. So notice the 4 steps I had here. Again, I'm listing what I want to find. I'm showing the work that I'm going to use to get there, or my formula. I'm substituting. This is just an extra step with conditional probability and then an answer. So those 4 components usually get you full credit. What are you communicating? What are you using? What does it look like? What is the answer? All right, so let's try this one here now, is that find the probability someone has a grade below a B, given that it comes from EPS. Now, again, the numerator is both, and it doesn't matter if it's L and E or E and L. But what changes is the denominator. I'm now looking at the new condition. Here I'm looking that it comes from the EPS. So here I still have 800 out of the 10,000. But down here now from EPS, that was going to be 1,600 out of the 10,000. So that turns into 800 out of 1,600. And that's going to be about 0.5. So we can see here, now we can compare these probabilities, that it's more likely that you are going to get a grade below a B, given that you come from EPS, than it would be to get a grade from EPS, given that the grade is below a B. A lot of hoopla, but it's really just practicing where everything goes. So let's look at what I did here, is that I have my 2 areas. So my first area here is the EPS school. So there's EPS, and then here I have below a B. So those are the conditions that I was looking at. Now notice that if my condition is below a B, that was the 800 out of 3,656. Whereas if my condition was EPS, that was 800 out of 1,600. And this is going to change depending on what the condition is. But notice that regardless of the condition, 2 of those variables are going to line up, and that is what we call the intersection or the both. That is our numerator. What's changing is what's available to the observer, which condition I have. So that's an example of something you might see on the AP exam. Frequently shows up on the FRQ and most definitely will be in the multiple choice. So what I need you to do now is actually simplify it, and sometimes those are even more challenging. Using your formulas, I need you to find these 3 probabilities. So pause the video, rewatch the example if needed, look at your formulas, try it out, and we'll come back together to solve the question. All right, so go ahead and pause now. Alrighty, so hopefully not too complicated to figure out. And if you got stuck, you can see here that I was stuck a bit, so I actually just used a 2-way table to help me out here. Now, probability of A given B, that's just our both over our condition. So I would take, here's my B probabilities, and then here is A and B. and that'll give me about 0.533. Same logic follows for now P of B given A. So now my new condition is event A. Now what's here, again, it could get wonky. You could have complements. So again, it's just both over the condition. So the condition is B. And now the both would be probability of A complement and B, which belongs to this area here. So 0.21 over 0.45. So it could ask you really for any variation, and having a two-way table readily available might be beneficial to you because then you can find those intersectional probabilities. Last thing I want you to note here is what happens between here in part A and here in part C. Notice that probability of A given B, probability of A complement given B. If I were to add these two numbers, they'd equal 1. So let's go back to this original diagram here. Here's all of event B. Here is not all, it's still all of event B, but it's either A happens given event B happens, or A does not happen given event B has happened. So really with these branches, the complement rule still applies. And so it doesn't really make too much sense now just with formulas, but in the next lesson when we look at probability tree diagrams, we'll see how we can use this complement rule with our probability tree branches. So for now, this is our intro to conditional probability, and in the next lesson, we're going to work with probability tree diagrams.